Graphing, so much fun, so much fun. Rational functions and their graphs. When we're looking at graphs, we can have a graph that goes on forever, meaning that you will never lift up your pencil when actually drawing it. We can have a graph that has a hole in it, so it's discontinued because it has a hole, so it's removable. This would be removable. This one would be non-removable, discontinuity, because of the fact that we have an asymptote. We're just going to get into right away, kind of looking and solving these things. Continuous means it will go on forever and you do not have to lift up your pencil. Discontinuous means that the fact that you either have a hole or else you have asymptotes. If it's removable, that means that you can actually cancel something out. Non-removable means that you can't cancel something out. We'll get into the problems so we can actually know some of these. This whole chapter you're going to be factoring a lot. So I'm going to factor this first one. So on top it still is going to keep as x plus 3. On bottom it becomes x minus 3 and x minus 1. Because it's two numbers that multiply to get positive 3 and add together to get negative 4. So first when I look at my discontinuity, it looks always at the bottom of the function. So right here, I can't cancel anything out, so I have discontinuity at x cannot equal 3, x cannot equal 1. That's also the domain. These are the domain restrictions here. This is non-removable, meaning that you did not cancel out anything from the two equations. Now when I'm finding my intercepts, same thing as before. When you find your x-intercept, that means you're plugging 0 in for y. When you're finding your y-intercept, you're plugging 0 in for x. So looking at this equation, plugging 0 in for y, we have 0 be equal to x plus 3 over x minus 3, x minus 1. When you're solving this, you want to get rid of this division. Now, you're going to multiply this whole thing on both sides of the equation. So it will be 0 times this whole thing. 0 times anything will be 0. So really, we're just focusing right here, because this kind of doesn't matter. So in a fraction, it's really on the top of the equation that will make it 0. So if I just focus on this blue part, I'm going to subtract 3 on both sides. So my x-intercept is negative 3. Plug 0 in for x. So y equals 0 plus 3 over 0 minus 3, parentheses, and 0 minus 1. And if you simplify that equation, you would get a positive 1, because you get 3 on top. This becomes negative 3 times negative 1, which is a positive 3. And then that is all the information I need to have. I want you to do B by yourself. I'm looking at C now, so pause the video, do B, and then watch the value of C. So I'm going to factor this. Two numbers that multiply to get negative 4, add together to get a negative 3 would be a negative 4 and a positive 1. On bottom, it's already at x minus 4. Before you simplify anything, you should find your domain. So in this case, x cannot equal a positive 4, because if I put a positive 4 right here, that would get 0, and that would be undefined. But now I look, because this whole thing can stick together, it has to stick together. You can only cancel if it's being multiplied. These two parentheses are the exact same, so these two parentheses together can cancel out. So my new equation would be y equals x plus 1. Now this is the equation I'm going to use. So this domain, the x equal or cannot be 4, this is removable, because we removed it from the actual equation. So x-intercept, if I plug 0 in for y, I have 0 is equal to x minus 1, or x plus 1, you subtract the 1, you get negative 1. If I plug 0 in for x, you have 0 plus 1, you get 0, 1. So this is the information that I would need for that question. So I want you to do D by yourself. You're looking at E, I can factor the top. You can't factor the bottom, it would be an imaginary number. So that should be a hint. Because when I'm looking at this domain restrictions apply when the bottom of the fraction would be equal to 0. If you look at this, if you can try to think of a number to plug in here that would create this to be 0, the only number that this should be would be a negative 3. This will never become a negative 3, because the fact that anything squared is always positive. So my domain here would be all real numbers. But I still have to find my x and y axis, or my intercepts, sorry. plug 0 in for x, plug 0 in for y. On top, I would get negative 1 over 3 when I plug 0 in for x, so that's negative 1/3. Bottom, again, we're just looking at the top of the fraction. So when you're plugging 0 in for y, you would get rid of this division, making it 0 times x squared minus 3. This cancels just to be 0. So then I actually want to factor this. So this could be x plus 1, x minus 1. These are x's. Plus. So I actually have two x intercepts. It could be x equals a negative 1. This right here would give me a negative 1. Or it could be a positive 1. Which makes sense because I can go through the x-axis more than one time with my branches. I want you to do the bottom one. And then that's all for this first section of 8.3. Have a great day.